The existence of an overwhelming amount of matter than antimatter in the universe is a fundamental question in physics. The violation of CP symmetry, the combination of charge conjugation and parity symmetries called CP violation, is one of the necessary conditions to explain this asymmetry. 50 years ago, Makoto Kobayashi and Toshihide Maskawa presented a groundbreaking study in Progress of Theoretical Physics predicting the existence of the third generation of quarks to account for the observed CP violation in kaon decays. Recognized with a Nobel Prize, this work has become one of the most influential papers in the history of elementary particle physics and the Standard Model. Over the course of these 50 years, the Kobayashi-Maskawa or KM theory has guided major discoveries, including the third generation of quarks, the mixing of neutral B mesons, the construction of B factories, and the CP violation of the B meson system. To mark this anniversary, Progress of Theoretical and Experimental Physics has released a new Special Topics edition, featuring 8 articles that highlight the impact of KM theory from both theoretical and experimental perspectives. This edition builds on the symposium Accomplishments and Mysteries in Quark Flavor Physics, 50th anniversary of Kobayashi-Maskawa theory, organized by the High Energy Accelerator Research Organization, or KEK. Starting with the theory of CP angle measurement, Amarjit Soni reviews direct and indirect techniques for the determination of unitary triangle or UT angles and their status, with special attention to the prospects of Bell II and Large Hadron Collider Beauty or LHCb experiments and lattice calculations. Stephen Lars Olsen revisits the lesser-known circumstances that occurred in the years before and after Kobayashi and Maskawa's paper, from an interesting story on the discovery of the charm quark to the corrections of the original matrix. Zoltan Ligeti discusses the past, present, and future efforts to determine the magnitudes of the elements of the CKM matrix and highlights the upcoming direction in flavor physics, including the search for physics beyond the Standard Model. Patrick Koppenberg focuses on the status of the LHCb, covering its history and current proceedings. The LHCb experiment has delivered unprecedented precision measurements for the KM matrix. Summarizing the status of kaon physics, where CP violation was originally discovered, André J. Buras reviews the recent strategies for determining the parameters of the CKM matrix without new physics infection. On the other hand, Taku Yamanaka reviews the contributions of kaon experiments in establishing the KM model, showcasing the search for CP violation caused by physics beyond the Standard Model. Nanae Taniguchi examines the prospects of the Bell II experiment in probing new physics beyond the KM model, covering recent measurements of the CKM parameters and rare decay processes. Finally, Gino Isidori explores the lasting impact of KM theory on flavor physics, which continues to be a probe for high-energy scale physics, and discusses the concept of flavor deconstruction and related extensions of the Standard Model. This collection is a tribute to the remarkable legacy of the KM model, which continues to guide the search for new physics beyond the Standard Model, advancing our understanding of the matter-antimatter asymmetry and fundamental nature of the universe.